Well, good afternoon, everybody, and welcome to our EVA status briefing here at the Johnson Space Center. I'm Dan Hewitt. Obviously, it's already been a very busy time for the crew on board the station and here on the ground in 2015. And it's not about to slow down. It's about to get a lot busier with 3 upcoming spacewalks. Here to learn a little bit more about what's ahead, again, for the crews and all of our teams down here on the ground. I'm joined by Todd, the International Space Station Operations Integration Manager. Tomas Gonzalez-Torres, the Expedition 42 Lead Flight Director. Then we have our trio of our lead spacewalk officers, starting with Karina Eversley, who will be the lead spacewalk officer for EVA 29, Sarah Korona, the officer for EVA 30, and Arthur Thomason, the officer for EVA 31. As usual, we'll hear from each of them, and then it'll open up for everybody's questions. So Kenny, why don't you go ahead and start us off?
Thanks, Dan. Well, as Dan said, it's been a very busy start to the year. We had SpaceX 5 launch earlier in the year. Just since the beginning of February alone, we've unberthed the Dragon. It arrived home safely. All of the cargo has been returned over to the owners. The science has been delivered to all the different scientists. So all very good news on that front. This past Saturday morning, for the final time, we undocked the ESA-built autonomous transfer vehicle, which, again, that was the last vehicle that was in that fleet. And so I would like to take this opportunity to congratulate our ESA colleagues. That was an outstanding program that they led. That particular vehicle serviced this program extremely well for a lot of years, and so our hats are off to them. Fresh on the heels of that undock, our Russian colleagues on Tuesday morning, very early, Houston time, launched 58 Progress, and that particular vehicle docked to the aft end of station yesterday around noontime here in Houston. Flawless, no issues, and so good. Again, we're glad to have that vehicle aboard as well. When we look forward, particularly on the EVA front, if you look out through the rest of the year, we've got about 7 EVAs on the schedule, 3 of which you're going to hear about today. The real goal as we start to turn the corner on the EVA front is to try to get us ready to prepare for the arrival of some of our commercial crew vehicles. You hear a lot about what's going on with the development of those vehicles at the different vendor facilities, but on the station we also have to do a lot of work to be ready to receive those vehicles, and so you'll be hearing about, at least on the EVA side of things, where we're going here with these next 3 EVAs. Looking forward past these EVAs, we'll start preparing for the return of Butch, Elena, and Alexander. That's going to happen around the middle of March time frame. And then a couple of weeks later, we're going to welcome Soyuz 42S, which will, along with it, bring us our first 1-year expedition crew, and Scott Kelly and Mikhail Kornienko. So we're very excited to have those guys on board. I think we'll learn a lot. I think the research team is going to learn a lot, and the lessons from that will pay big dividends as we go forth as a program and as a nation, and try to explore beyond low Earth orbit. So we're looking forward to getting those guys on board. Shortly after they arrive, we'll be looking to bring the SpaceX 6 Dragon on board around the middle to end of April. Still working through the details of the schedule, but that'll be roughly the time frame that we're talking about, and we'll have a very involved heavy science mission with SpaceX. So with that said, it's going to be a very busy springtime. When we start to turn our eyes towards the summer and the fall, we're really going to put a lot of attention and focus on expanding and in some ways reassembling part of Space Station to allow ourselves to establish some berthing ports for all the different commercial vehicles that'll be coming to station. In general, what we're trying to do is establish 2 berthing ports for each of the types of cargo vehicles that we're having. We'll have cargo vehicles, and we'll have crew vehicles. and we want to make sure that we have primary and backup ports for each one of those. And so as we start to transform station a little bit, in the middle of the year, you're going to see us do some robotics work. We're going to take the permanent multi-purpose module that's on the nadir side of Node 1, and we're going to move it up to the Node 3 forward area. And what that's going to do is that's going to open up the Node 1 nadir as a cargo vehicle berthing port. And we have to do that because the Node 2 Zenith port, which is currently our backup port for berthing cargo vehicles, we're going to transform that and make that one of our ports that we're going to put the crewed vehicles on when we start receiving those here in the next couple of years. And so a lot of what's going to be going on through the EVAs as well as on the internal side is starting to outfit the front end of PMA2. We're going to move PMA3, move it over to that Node 2 Zenith location, and that's where we're going to be prepared to receive crewed vehicles, is on Node 2 forward and Node 2 Zenith. So again, I say all that to say we're doing a lot of reconfiguration this year. So in addition to some long duration science and some cargo ops and all the other things, we really are trying to take station into this next phase in support of the commercial industries and providers. But as I said earlier, it all kind of gets started here in the next couple of weeks with this series of EVAs. So far, the preparations are going, I think, reasonably well for the EVAs. I did want to mention to you that we have what I consider to be one piece of non-standard open work. In general, when you're several days out from an EVA, you're still trying to tidy things up and get the products done and get ready to go out to hatch. So we tend to divide things in terms of standard and non-standard. And so we do have what I consider to be one non-standard piece of open work. A couple of months ago on orbit, during one of our suit maintenance activities, we had one of the suits, and we were trying to do a loop scrub activity with it. The suit didn't, the fan pump SEP inside that suit did not spin up. And as most of you know, that's the same area of concern that we had back in 2013 when we had the issue with the water in the helmet. So obviously it gets a lot of attention, and people want to try to understand what's going on. So we did some troubleshooting. At the time, our best guess was that there was mechanical binding in that fan pump SEP. The fan itself wouldn't turn. We put a new fan pump SEP in that we had on orbit, and it's been working with no issues since that point. Subsequent to that particular failure, in January, we had a second suit. We were doing the same type of activity and encountered the same type of failure in the fan pump SEP area. And that got us thinking, what's changed, what's happening. It appeared to be the same type of mechanical binding issue, and we did some more testing on orbit. We couldn't directly get into the fan pump SEP. It's all a single unit. And so we didn't get into it, but we kind of got enough data in and around it through our testing on orbit to say that we still felt like it was mechanical binding. We took the opportunity, in fact, very late in the SpaceX flow to pull that particular fan pump SEP along with the one that we pulled out in December and return those two fan pump SEPs on SpaceX 5. Since that time, the team responsible for the engineering on our suits and our engineering teams here have been working exhaustively to try to understand exactly what was going on. The thought going into the initial evaluation of the pump SEP issue was that perhaps we might be getting water in some other places of the fan pump SEP, and as they began to look at particular parts of the fan pump SEP, in particular the bearings, it all started to make sense. We're seeing binding, and at the same time we're seeing, when they got inside them, they're seeing some corrosion there. So all the evidence is lining up to say that we're getting water in and around some of the bearings inside the fan pump SEP. If you look at the unit itself, it's the fan and the pump separator are attached to a drive shaft that run back to the motor. And there's two sets of bearings, and the bearings that are closest to the fan are the ones that we're seeing this corrosion on. And when you look at some of the things that we've done since 2013, when we had the water and helmet issue, we've implemented a lot of different tests that we're doing, samples, if you will, that allow us to get some insight into how the water chemistry is within the suit. And we do that as part of our normal maintenance activities. And what we're discovering is that it looks like that with the number of times we're powering on this fan pump set, in doing so, we're actually putting a little bit more water in each time we're doing that. And over a period of time, we're putting enough water in there that once you disengage the suit and power it down, that water sits in that area in the fan pump set and it eventually migrates into these bearings. And so at this point, we're pretty certain that's what's going on. That's the method by which we're getting the extra water in the suit. We never had this issue before, but we're putting more water in this particular area of the fan pump sub now as a result of doing the extra sampling. And so we're off to take a fresh look at how we ensure the water chemistry stays good. We think we've come a long way in our understanding of that, and feel very confident that the water quality itself is no longer an issue. And now we just need to go back and relook at our sampling techniques and make sure that we're sound there in our thinking, and that we're not doing anything to further damage the pump seps that we have on orbit. So where does that leave us now going into these EVAs? The two suits that we have on orbit that we're going out EVA with at this point have operated every time we've turned them on. We're looking at the data constantly every time we turn them on and put them through their paces. There's, at least on one of the suits, some evidence, if you will, that there may be some corrosion in that bearing area. And so the team at United Technologies and our engineering guys here are working very hard to understand what the level of corrosion might be, and whether or not it has any impact on our ability to keep the fan operating during the EVA itself. All indicators are, based on all the data from the ground testing as well as the testing of the suits on orbit, is that we'll work our way through this, and these suits are going to be okay. But that said, we have some open work left to do. That's the non-standard part of this that we have to get worked out over the next few days here. And at the end of the day, we're going to be data driven. We'll do these EVAs when the timing's right, when we're sure that we got suits that we have high confidence we can go out the hatch with and do the tasks that are before us. These tasks are not going to be easy, the ones that we're talking about here, and so we want to ensure that we put ourselves in a position for success when we do go out the hatch. So anyway, I'm very, very confident that we'll get there with that. One thing I do want to make sure that I touch on with you guys, because again, we talked about the fan pump SEP and we talked about the water and helmet issue. With the water in the helmet, that was a totally different root cause issue. That was an issue with portholes getting clogged up in the water separator. That was due to the water chemistry issue that we talked about earlier. And through that clogging, water was allowed to get into the vent flow that goes up into the helmet. That is not an issue here. What we're talking about is a failure of the pump to start up. That in and of itself is not a water type of event where you could get water in the helmet. In fact, our ops team here will tell you this is something that they train for. They understand that they have cue cards, checklists, cuff lists for when a fan pump fails off. So this is, a fan pump could fail for a variety of reasons. We've just found one here based on this corrosion that's getting in the system. So again, we'll go work our way through that, and we'll be data driven. We'll do the EVA when it's ready. At this point, I'm going to do an IMMT tomorrow morning. We'll see where the different teams are, where we're at on our data. We're continuing to meet this afternoon. We'll at a technical level, and then we'll circle back up as a program in the morning and figure out when the right time to go do these EVAs are, but I'm optimistic we'll be going out the hatch very soon here. And with that, I'll pass it over to Tomas.
Okay. All right, thanks a lot, Kenny. So I am Tomas Gonzalez-Torres, increment lead flight director for increment 42. I'm going to give a really high big picture, and then I'll let the experts here talk in details about the specific EVAs. These EVAs are going to be numbers 29, 30, and 31. All of them expected to have egress start time right around 6:15 Central Daylight Time, and each expected to last right around 6.5 hours. All three of them will be in U.S. spacesuits and will be egressed from the U.S. Quest airlock. The EV crew members, the crew members that will be performing these EVAs are Barry Wilmore, we call him Butch, and he's going to be EV1 for EVAs 29 and 30, and then Terry Virts, and he will be EV1 on the third EVA in the series, EVA 31, or spacewalk number 31. This will be Butch's second, third, and fourth EVAs, and Terry's first, second, and third EVAs. On the inside of the space station, Samantha Cristoforetti, the other USOS crew member, will be helping to suit up the crew before they go outside, and she will also be helping on the second EVA in the series, number 30, with the robotics operations. The lead flight directors for these EVAs are going to be Tony Sakachi for the first and third EVA, or spacewalks in the series, and then Greg Whitney will be the lead flight director, for the second EVA in the series. As Kenny mentioned, overall, over the next several months, the ISS is going to be going through some reconfiguration. A couple of the items that we're going to be doing are specifically relocating the PMM module from the Node 1 nadir to the Node 3 forward. So it's going from the blue spot in the picture to the green spot. And then the other relocation is going to be of the PMA 3 moving from Node 3 ports to Node 2 zenith, again from blue spot to the green spot. And all of this is to helping, again, provide new berthing ports for future vehicles. In addition to the PMA relocations, on the ends of those PMAs, in the near future, some IDAs, or international docking adapters, are going to be flown up, and those going to be attached again to the PMAs themselves. And these EVAs, or spacewalks coming up, are specifically supporting the external reconfiguration of the ISS so that we can support these objectives and these new berthing ports. The main objectives of the upcoming 3 spacewalks are pretty focused on a couple of things. For EVA 29, it's all going to be IDA cable routing. Then EVA 30 will complete the cable routing along with some SSRMS, the end effector lead lubrication, and then also on EVA 31 is going to be the C2V2, or the common communications for visiting vehicles cable routing. And with that, that's the high level. I'll go ahead and pass it on to Karina Eversley to begin with the first EVA.
Thanks, Tomas. I'm Karina Eversley. I'll be the lead EVA officer for the first EVA in the series. I'd also like to acknowledge the rest of my team. I have Scott Ray, Sandy Fletcher, Brian Alpert, and Ernie Bell that will be working with me during the EVA. And the goal of US EVA 29 is to lay the cables that will provide the power and data for the International Docking Adapter number 1 that's going to be installed on the forward end of PMA number 2 later this year. This will be the most complicated cable routing task that we have performed by EVA on ISS to date, and I should state that there is an equally complicated set of cable routing that has to be done internal to the space station as well. This photo here shows the forward end cone of Node 2 and the PMA 2, and that's the overview of the work site that we'll be working in for the entire EVA. You can see 2 of the micrometeoroid orbital debris shields that are pointed out there. The crew will have to remove those 2 shields in order to make several connections. And this will be the first time that we've opened this type of end cone shield although we have opened a circumferential shield of this type in the past. The connections underneath these shields were never expected to be operated by EVA crew members, and so they were designed with a different type of a connector, one that's commonly used inside the space station instead of our typical EVA connector. And I have a couple of examples to show you. So this is the standard EVA connector that we use, and you operate it by pulling a lever back and then separating the two halves, realign the two halves, and push the lever forward. And it was designed to be more easily operated by somebody in a spacesuit glove. The other connectors that we will have to use on this EVA require a 360-degree rotation of a collar. And then in order to mate them, you have to actually align the keying features, which can be a little tricky to do, and rotate the collar back. And that rotation is difficult to do in the gloves, as well as all the alignment that's required of that type of connector. The crew will be making 5 of that type of connection under these shields, 4 under the port shield and 1 under the starboard shield. And although this will be the first time that the ISS EVA crew has had to operate this type of connector, we have used these connectors before on the Hubble Space Telescope servicing missions. And actually, if the crew does have difficulty with these connections, we have a Hubble-designed tool that's basically just a spring-loaded set of connector pliers that we can use to get some additional leverage on that collar. Okay, and I think I have another graphic that shows the view of what the cabling will look like in its final configuration when the IDA is in place. One thing to point out here are the 2 connector panels on the IDA. You can see one on the starboard zenith quadrant, which is on the right-hand side of the picture, and then there's a second one directly nadir that's just out of view here. And we will be stowing the ends of our cables on the PMA near those 2 locations, so they'll be waiting there for when the IDA arrives. For some fun facts on the cables that we'll be routing on this EVA, there are 10 cables total that branch into 21 different legs. This is the set of cables in one of the bags that you see. So there's a total of 364 feet of cable that the crew will be routing between the first 2 EVAs. And the longest individual run of cable the crew will deploy on this EVA is 43 feet. It happens to be the second one that's colored purple in this view. To help the crew keep track of all the different cables and the different legs, we actually added colored patches periodically along the cables. And we do use those colors extensively in our procedures and the graphics that we use, as well as the movie that you'll see in just a moment. The cables will be transported to the worksite in specially designed bags, and each bag has 3 layers inside, and each layer has several straps to hold all the different legs of the cables. We packed the cable bags on the ground with the cable legs going in according to the order in which we need to deploy them. Okay, and with that, I will start the movie. Okay, so on this first EVA, Butch Wilmore is going to be EV1, and he'll egress the airlock first, wearing the suit with the red stripes. And he'll bring out a large bundle consisting of the IDA cable bag and a crew lock bag. And then Terry will egress with the pure white suit and carrying an identical large bundle. Butch will translate up the CETA spur and over to the port zenith side of the Destiny lab, and then to the forward end cone of the Harmony node. And that, of course, is using the handrail path you see blinking there. Meanwhile, Terry will translate around the perimeter of external stowage platform number 2 and along the starboard side of Destiny and Harmony to the forward end cone. And once there, both crew members will stow their crew lock bags and the IDA cable bags near the work site. And they'll then spend some time installing wire tie restraints on the PMA2 along the routes that the cables will follow throughout the rest of the EVA. And you can see in this video from the training in the neutral buoyancy lab, they're wrapping wire ties around handrails and different things that we can then use to restrain the cables. Finally, Butch will move some of the existing PMA2 cabling to get it out of the way for removal of the first shield. You can see that it's routed across the shield that we need to open. So Butch and Terry will work together to release the 3 bolts holding the port shield in place and move it out of the way. And Terry will open the port IDA cable bag. Butch will disconnect the 4 existing cables under the shield, which previously provided services for the space shuttle and still do provide the heater power for PMA2. One by one, Terry will hand him 4 new IDA cables to connect. And on this graphic here, you can see on the left side is the current configuration with red circles around the 4 that Butch will disconnect. And on the right side, you can see the 4 new IDA cables connected, with the light blue and the dark blue cables are actually routed underneath the handrails, and the other 2 are routed past the handrails. And in that way, the cables actually fit into gaps on either side of the handrail so they can exit from underneath the shield. So once all 4 cables have been connected, the crew will reinstall the shield and then translate to the other side, where they will swap roles. Butch will open the cable bag. They'll work together to open the shield. Terry will disconnect the existing cable, and Butch will hand him the new IDA cable to connect. And then they'll reinstall that shield. And before leaving the starboard cable bag, Butch will retrieve a cable from it and bring it to the port side of Harmony, where he'll attach it to a handrail and begin uncoiling it. He'll first follow the handrail path you see highlighted in yellow to unroll the cable aft towards the Destiny lab, where he'll make 2 connections. And then he'll come back forward and stow a leg that will ultimately go up PMA3 towards IDA number 2 later on. And finally, he'll take the remaining leg and uncoil it as he moves forward, securing the cable in the wire ties that were installed at the beginning of the EVA. And the remaining coil of cable will be stowed on PMA2 until IDA 1 arrives. And that's the longest of the cables on the EVA. Meanwhile, Terry will begin unpacking and routing cables from the port cable bag, starting with the 2 cables that restore power and telemetry for the PMA2 heaters. And he'll be making the 2 connections that you see there labeled as P1 and P2. Now, each of these 2 cables has a leg that continues forward towards the forward end of PMA2. One of them goes zenith, and one goes nadir. And these are stowed near those locations I pointed out earlier where the connector panels will eventually be. So for the remainder of the EVA, Butch will deploy the cables that follow the port nadir route, and Terry will deploy cables that follow a zenith or starboard path. And you'll see that we just continue stowing the cables on the PMA near where those connector panels will be, and they tend to follow sort of highways, and so that's the route that we put the wire ties on at the beginning of the EVA. The final set of cables that Butch will stow are 3 legs that will ultimately go to IDA number 2. And once we have those stowed, that will empty out the port cable bag. And during that time, Terry finishes his last cable on the starboard side. And that cable has an IDA 1 leg and an IDA 2 leg that gets stowed on the node 2 forward end cone. At this point, there will be 2 cables remaining in the starboard cable bag, which will be deployed on the second EVA, and Sarah will be providing the details on those in a few moments. The crew will pack up their crew lock bags, and the port IDA cable bag will leave the starboard IDA cable bag there with those 2 cables in it. And the crew will follow their original translation path back to the airlock. If we are ahead on the timeline on this day, we will go ahead and finish as much of the cable routing as time allows, and so that's our only get ahead for this EVA. So that covers the first EVA in the series, and I'll hand it over to Sarah Korona to talk about the second.
Thank you, Karina. I am Sarah Korona. I'm the lead spacewalk officer for EVA 30. Also like to recognize the folks who will be in the back room for this EVA. Farouk Sabor and Ali Batcaletti will be on the task side, and Brian Elpert and Paul Dumm will be on the system side. And as it's been mentioned, Butch Wilmore is going to be EV1 for this EVA, and Terry Virts is going to be EV2 with Samantha Cristoforetti. She is going to be the IV crew member. Getting into the details of the EVA, I think it's best to just go ahead and roll the video. So let's go ahead and start the video. So on US EVA 30, with Butch Wilmore being EV1, he is going to be wearing the red stripes on the spacesuit. And Terry Virts being EV2, he is going to be wearing the white stripes on his suit. So both crew members are going to egress the airlock, which is going to be egressing first. And you see Terry, who's going to be translating to the lab forward end cone, very similar translation path to the first EVA. And he's at that end cone, he's going to be putting some inhibits in place that is required for mating and demating some cables. That's for the IDA task. So he does some on the starboard side, and then he goes to the nadir side to essentially unplug this visiting vehicle power so that during the EVA we are not making any hot mates or demates. Meanwhile, Butch is going to be translating to the node 2 zenith forward end cone. Again, a very similar translation path that he had for EVA 1. And he's going to be going to PMA 2, the pressurized mating adapter, same worksite location as EVA 1. He's going to be setting up that area, setting down a bag in which they are going to be removing the PMA 2 cover. So this cover acts as a thermal and micrometeorite protection, and we need to remove it because this is where IDA 1 is going to be installed. So both crew members help in that removal, and they pack up that cover and put it into the bag. Once that's complete, the crew is going to finish up the cable routing that was not completed on the first EVA. So Terry's going to be working on the starboard side. You see him right here. He's mating and demating some connectors. This is what those inhibits were needed so that none of these connections that he has will be hot mates or demates. So Butch is going to be on the port side, and he's essentially going to be doing the same thing. You'll be seeing him mating and demating some of those connectors here. And once the connectors have been connected up, they are going to continue the cable routing of that. As Karina mentioned, some of these are for IDA 1 and some of these are for IDA 2. Moving back over to Terry with this orange cable, you'll see this orange cable going up to the node 2 forward end cone, and that will be needed for IDA 2 connections. Moving back over to Terry, the cables that are going to be at the PMA 2 nadir location, that's for IDA 1. And then you can see him routing the ones that are going to be needed for IDA 2, again on that node 2 forward end cone. And that should complete all of the IDA cable routing that's required for these EVAs. Once that's done, Terry's going to head back to the lab forward end cone and basically plug back in that visiting vehicle power. So those inhibits he put in place, he's going to go ahead and mate those back again. And both crew members are going to help with the cleanup at the work site of PMA 2. Terry is going to go ahead and pick up that bag that was left out on EVA 1 and bring that back inside in the airlock. And Butch is going to grab the bag that has the PMA 2 cover in it and bring that back to the airlock. And so they stow both of those bags inside the airlock, and then they grab the bags that they will need for the rest of the tasks for the EVA. So Terry's task is going to be on ESP2, which is the external stowage platform. He is going to be reconfiguring a foot restraint, and he will then go ahead and ingress into that foot restraint so he can complete the lubrication of the space station remote manipulator system, the SSRMS latching end effector, the LEE. And so Samantha Cristoforetti, she's going to be the robotics operator for the EVA. So Butch and Samantha are going to be, Terry and Samantha are going to be talking throughout the EVA, making sure that the arm is in a location where Terry can get to the lubrication that's required. And so we are going to be essentially lubricating 5 different portions of the lee, the latching end effector. This picture shows the face of the lee, and you can see that there are 4 latches on it, labeled latch 1, 2, 3, and 4. And the next picture shows these latches in the extended position. So while the latches are extended, we will be able to lubricate the latch ball screws, equalization brackets, and latch deployment rollers. This next picture shows the latches in the retracted position, where we can lubricate the linear track bearings. Another thing that we're going to be lubricating is the rigidized central ball screw. So in this video, you can see that this ball screw is right in the middle of the lee, and they are going to be putting grease on a tool and getting the feel for what that ball screw feels like through the gloved hand in using this tool. And so you can see it, and the reason we're doing that first is because we really want to get Terry to have that feel of how it feels to lubricate, because the next task is going to be lubricating a similar ball screw for the latches. And so in this video, you can see they're going to insert this tool into the cavity of the latch, and it is all going to be a blind operation. He's not going to actually physically see the ball screw that he is lubricating, and that's why we want him to make sure he is comfortable so that he knows he is lubricating the portion that we would like. So this is showing what it will look like on the inside of that latch and spreading grease all along that ball screw. Again, Terry's not going to be able to see that, but this is what it will look like. Once that lubrication is complete, we're going to go ahead and retract the latches so we can lubricate the linear track bearings. So each latch has these 2 track bearings, and we're going to lubricate both sides of those tracks on each of the 4 latches. If there's enough time in the EVA, we're going to go ahead and continue lubrication. We're going to extend the latches again to lubricate the equalization brackets as well as the deployment rollers. So in this picture, again, of the extended latch, you can see the equalization brackets. So each latch has 1 equalization bracket, and then there are 4 latch deployment rollers per latch. So for the latch deployment rollers, we're just basically putting a little dab of grease onto the rollers, and the equalization bracket, we put a little grease along the inboard and the outboard sides of that bracket. Meanwhile, Butch is going to be doing the PMM prep portion of the EVA, so the permanent multipurpose module. On his way to the work site, he's going to go up to the Z1 port toolbox, where he's going to get a socket that's required for the work site out at node 3. So you can see his translation path out to node 3. First, he's going to go to the forward side of node 3, and he's going to be removing a non-propulsive valve, an NPV, that when we are relocating the PMM, it's a very tight clearance of that relocation. So we'd like to remove this valve during this EVA, and then in its place install a vent cover plate. So that is the valve that we're going to remove, and that vent cover plate is installed. We install that cover plate to protect the sealing surfaces of that valve, because once the PMM is relocated here, we do have plans to reinstall that valve. Once that's complete, he moves to the starboard side and is going to be removing a handrail that has actual physical interference when the PMM is relocated here. So we will not be reinstalling it. Next in view is the CBM, the common berthing mechanism. And this is actually where the PMM is going to be relocated. And so there are some launch locks that need to be released, as well as a flap that needs to be opened for some camera views. So on the CBMs, there are 4 pedals, each that has 2 launch locks. And so Butch is going to be releasing all 8 of those launch locks on this CBM. When he is complete with the forward side of node 3, he's going to translate over to the aft side. You can see his translation path here. So the aft side, going to that CBM, and essentially doing the same thing. In this location, is where the beam experiment, the Bigelow Expandable Activity Module, is going to be berthed to. And so again, he needs to release the launch locks of all 4 pedals and then open up the flap that's needed for the camera views. So once all of the launch locks are released, and this is for both the forward and the aft CBM, the ground is going to command these pedals open to a 45-degree position, and Butch is going to verify that they did deploy in that position, and then the ground is going to go ahead and close them, and Butch is going to verify that they are closed. Once that's complete, he's going to head back to that toolbox, put his socket away, and head on back to the airlock. And so Butch and Terry will be back at the airlock, and that's the planned tasks for this EVA. We do anticipate we'll have some time for the get-aheads. The first get-ahead, we would be putting wire ties on the S0 truss, and this is getting a head start for the 3rd EVA. Another task we can do is to be removing a light that's on a camera port that's the P1 lower outboard work site. So the light is dim there, so we'll bring the light inside and get that fixed. Another task would be reconfiguring the CETA cart. The CETA cart's the crew and equipment translation aid. So we basically want to put these in a lower profile for the MT, the mobile transporter, so it won't have any clearance issues with it. So we tie some brake handles back. We go ahead and we remove a coupler. There's the coupler shown there, and also a swing arm. So we remove the coupler and the swing arm, and we pull those off and translate over to along the truss to S0, where we're going to go ahead and stow that out of the way on the wedge face there. This is showing the port CETA cart, where at this location, all we would need to do is take a tether to tie down these brake handles. Another task we can do is back at the airlock. There is a known sharp edge along the handrail of the airlock, and so we have a handrail clamp that can go over that sharp edge. You can see it here in the picture. So we install that, and so since this is such a highly traveled area, we install that clamp, and then the crew doesn't need to worry about cutting their glove or anything else on their spacesuit when going over that handrail. And so that is the get-aheads that we can do for this EVA, and that's it for the video. I also have some tools to show you of how we're going to be doing some of the lubrication. So this was, the Lee was never intended to be lubricated in this manner, so we developed what we call the BLT. This is the ball screw lubrication tool. It's made out of a probe and some wire ties and lots of tape on it. And so we have a grease gun that Terry's going to be inserting the grease on right into this little cup holder here, and then inserting this into the latches on the Lee. We also have several of these EVA wipes that we'll have at the work site, just to contain grease. You know, things can get greasy. And so we've got wipes that you can use to catch any of the grease that's needed. Okay. And those are the details I have for EVA 30. With that, I'll pass it on to Art Thomason to talk the details of EVA 31.
Great. Thanks a lot, Sarah. Hello, I'm Art Thomason. I am the EVA officer for US EVA 31. During the development of this EVA, I've had the privilege of working with an outstanding team. I'd like to recognize Jordan Lindsay, David Simon, and Brian Alpert for all the great work they've done in getting us ready to perform this EVA in space. I'd also like to recognize the crew that will be performing this EVA on orbit. We have Terry Virts, Butch Wilmore, and Samantha Cristoforetti. Terry will be coming out in the suit with the red stripes indicating he is the lead spacewalker, or EV1. Butch will be wearing the suit with the white stripes as EV2. And then Samantha will be the IV or intravehicular crew member. She'll be helping both Terry and Butch get suited up for this spacewalk and out the door successfully. Now, the purpose of this EVA is to install the Common Communications for Visiting Vehicle System, or C2V2 as we call it. Excuse me. C2V2 will aid visiting vehicles in rendezvous and docking with the International Space Station. Now, this system, the C2V2 system, consists of 2 booms 4 antennas, and 3 reflectors. On this EVA, we'll also be routing 400 feet of cable. This cable consists of 4 100-foot legs that will be routed from the center of the space station out to each antenna. Now, fortunately, Butch and Terry both had an opportunity to see this hardware during training in the Neutral Buoyancy Lab, so they're definitely familiar with the hardware. Since they've seen it, we've tweaked the plan a little bit to increase efficiency, but we've uplinked procedures, briefing packages, and videos to make sure they have all the details they need to perform a successful spacewalk. With that, we can get into more of the details and the choreography of the spacewalk, so I'd like to roll the video. So starting out for US EVA 31, Terry will come out first. He'll be the lead spacewalker, wearing the suit with the red stripes. Butch will pass out the large ORU bag with the 4 cable reels in it. He'll also pass out the larger of the 2 booms, the P3 boom, and Butch will come out with the shorter of the 2 booms that will be going on the starboard side. Here you see both booms. The boom on the bottom is the port boom that Terry will bring out. It has a reflector bag and an antenna bag attached to it. The boom at the top of the page is the starboard boom that Butch will bring out, and it has an antenna bag on it. Here you see the antenna bag, the hi-fi hardware. We configure the antennas in this way to protect the delicate surface on the end of the antennas. Here you see an antenna. In the upper right-hand corner, that white surface is the area that we're trying to protect. We also have a protective cover that will be installed on it. You see that cover at the top of the screen here. At this point, both crew members will head to their respective work sites. Butch will head starboard, and here you see Terry headed port. Terry will translate over the rat's nest. We call it that because of all the cabling in the area. So he'll continue out to the P3 or port 3 truss. There he'll install his boom into a worksite interface or WIF. This WIF is typically used for foot restraints for crew members, but this hardware has been adapted to install into this mechanism. Once he gets the boom installed, Terry will remove both bags and stow those on structure. He'll then open up the antenna bag. You see that opening up here, flashing. He'll remove both antennas and install them on the boom. From there, he'll remove the protective cover from the antennas and stow those in the crew lock bag. Here you see the antennas in their final configuration. We have both antennas installed. We also have retro reflectors installed. We're going to wait till the end of the EVA to get these installed because they're delicate and we want to protect the glass on those reflectors. So meanwhile, while Terry is working on the port side, Butch will head out to the starboard side. He'll head out to S3, or the starboard 3 truss. He'll install the shorter of the 2 booms in S3 WIF 13. Once he gets that installed, he'll move his crew lock bag with antennas in it off to a handrail. And then he'll open up that bag and install both antennas into the boom. He'll use a pip pin or pull-in, pull-out pin to secure these to the boom. Once both are installed, he'll remove the protective covering from the antennas. At this point, he'll close up the bag and leave it at the work site because we'll use it to bring back in caps later in the EVA. So at this point, both crew members will be headed back towards the US airlock. Here you see Butch headed back to the large ORU bag. This contains the 4 cable reels that will be deployed during the EVA. He's going to move this bag to the US laboratory to get it in close proximity to the debris shield that the Z2V2 system connects under. So here you see Butch and Terry working together to remove the debris shield. They'll demate a connector under that shield and mate the C2V2 connector, and then reintegrate this J7 connector that they demated into the C2V2 cable. Here you see the J7 connector that the crew will demate. This actually runs to GPS and KU band antennas. Here you see the C2V2 connector. The connector on the left is the one that will attach underneath the shield. The one on the right will reintegrate the GPS and KU band system. The crew will then work together to reinstall the shield. At this point, Butch will head over to the large ORU bag and he'll retrieve 2 cable reels. He'll hand one to Terry, and he'll keep one for himself. And they'll get ready to route the port legs. Here you see 4 of the cable bags. These bags are all tied together by one connector that you see at the bottom of the page here that connects underneath the shield. Here you see the 100 feet of cable coiled up inside of one of the bags. As I mentioned, both crew members will be getting set to head out port for their routing. This graphic shows the 2 legs that route port, which they'll take care of first. Once that's complete, they'll route the 2 starboard legs that head out to S3. So Terry will head out first. He'll translate over the rat's nest. He'll be taking the aft translation path on the port side of the truss. And along the way, he'll be securing this cable with copper wire ties. And that will secure the cable to handrails to make sure that it doesn't move and cause any issues. Once he arrives at the boom, he'll remove 2 caps from the antennas. These are to protect the electrical connections. He'll then remove the remaining slack out of his cable bag, and then he'll mate that cable to the inboard antenna. Meanwhile, Butch will be following Terry about 20 feet behind. You can see his cable routing path here. As he translates along the rat's nest, he'll be actually putting both sets of cables into one set of wire ties until he gets to the point that you see here. At this point, Butch will break off and start routing his cable on the forward path along the nadir side of the port truss. This will separate both cables by about 18 inches, and it'll protect the system from being taken out by a single debris strike. So once Butch arrives, he'll hand his cable off to Terry. He'll mate that to the outboard antenna, completing the connections on the port side. So the last thing to do at this work site will be to install 2 retro reflectors onto the boom. Terry will take care of that. Here you see the reflectors that will be used during this EVA. It's used for visiting vehicle range finding. You also see the delicate glass surfaces that we're trying to protect, and that's why we want to install these last thing before we head out from the work site. At this point, they'll start cleaning up this work site. Butch will take the reflector bag, Terry will take the reflector bag and bundle that to his empty cable reel bag. Butch will take the antenna bag and he'll bundle that with his empty cable reel bag. Both crew members will head back to the US laboratory. They'll stow their empty reel bags and the empty crew lock bag in the large ORU bag. And they'll both pick up a cable reel. And this time they'll head out starboard. Butch will lead this time, and here we see Butch's translation path. He'll take the aft path out to S3, and Terry will be taking the forward path. Once Butch arrives at S3, he'll get ready to remove the 2 protective caps from the antenna. He'll stow those in the crew lock bag. Then he'll remove the remaining slack out of his bag and attach that to the inboard antenna. At this time, Terry should be arriving at the work site. He'll drop off the reflector bag and leave that for Butch. He'll then pick up the crew lock bag that now has caps and protective covers in it, and he'll bundle that with his empty cable reel bag. Terry will then pull out the remaining slack of his cable, hand that off to Butch, and Butch will mate the final connection to the C2B2 system, the outboard connector on the starboard boom. At this point, Terry will head back towards the airlock. He'll take his empty reel bag and crew lock bag. He'll stow those into the large ORU bag and get this ready to bring back inside. Meanwhile, Butch will finish up out on the starboard truss. He'll install the final retro reflector onto the starboard boom. Once this is complete, he'll take the empty reflector bag and he'll stow that on his cable reel bag and head back to the airlock. Butch will ingress first with those 2 bags. Then Terry will pass in his large ORU bag. And then Terry will ingress. and he will close and lock the hatch, completing US EVA 31. Now, during the video, I did mention that we have a cable reel bag. Showed you some pictures of that. This actually shows this is a mock-up of the bag. So on the ground, we packed this bag with 100 feet of cable in it. See if I can get it open here. So the reel, this is the reel here. The connector that attaches to the antenna installs into this slot, and then we reeled up all 100 feet of cable onto this. So then when the crew gets it, they see a bag like this with a small slit of the cable coming out. So when the crew translates out to their work site, the cable deploys automatically as they head out. This bag also has pockets on each end. These pockets hold wire tie caddies. These wire tie caddies hold 9 wire ties each. These wire ties are used to secure the cable back to structure. I think that concludes the US EVA 31 briefing. I'll hand it back to the moderator for questions.
All right. Thank you again to all of our panelists for walking us through that. And again, we'll open it up for questions now. We're going to start here in the room and then go to the phone bridge and then take a couple off of social media. If you're on the phone bridge, go ahead and press *1 if you have a question to get added into the queue. Okay, I always go left to right, so let's start with Eric.
Okay. I guess a question for Kenneth, Todd. So when all the work is done, including these EVAs and others I suspect later this year, sort of describe to me the situation with the ports. How many ports for docking will you have, and is each of them assigned to a specific kind of vehicle? And so how many will you have for the Russian vehicles, how many will you have for Progress, and so forth?
Sure. When you look at the USOS, our goal by the end of the year is to have 2 berthing ports for the commercial crew vehicles, and those ports will be node 2 forward, where the PMA2 is right now, and we'll have an international docking adapter at that location. We'll also have one on the node 2 Zenith location, which by that time will have PMA3, pressurized mating adapter number 3, relocated to that Zenith port, and we will also put an IDA on that one as well. So those will be our 2 ports for the commercial crew vehicles, and either one of the folks who are currently building that hardware can come to either one of those ports. So there's no issue with that part of it. As far as the cargo vehicles, we'll have the node 2 Nader location that we currently use today. That's our primary location, but because we're taking the backup port that's up on top, the node 2 Zenith, and making that a crewed vehicle port with an IDA and a PMA on it, now we have to create another one. So that's where we'll put the node 1 Nader location will become the second port for berthing of commercial cargo vehicles. So if you think of it, 2 Nader ports for the commercial cargo vehicles, and then you have the front and the Zenith for the crew vehicles. That's right, 2 for cargo, 2 for crew. And then when you look on the Russian segment, their number of ports has not changed any. They'll still have the FGB location, which they have MRM 1 there now, and that's they dock a Soyuz there at this point. They also have MRM 2, where which is up on the Zenith side, which is where they dock also the other Soyuz. And then in addition to that, they dock Progress vehicles currently on the aft, which is where they docked yesterday, the aft part of the service module, and then also in the docking compartment, they dock a Progress there as well, which is on the Nader.
So also you'll have 8 ports on station?
Correct.
Okay. Gina?
How much has the supply chain been a challenge for you in configuring these spacewalks?
I don't know that it's been that much of a challenge. I mean, certainly, I think we're starting to get up and running pretty good with the commercial cargo capability, and you know, that's going to be key to us in terms of being able to do the job that we've set out to do this year. The SpaceX vehicles have to bring the docking adapters for us. So in terms of the logistics part of it, it's going to be critical, but very much doable. I think we'll still be able to maintain a healthy science complement throughout if we're able to get all the SpaceX flights we need this year. As well, we'll have an HDV flight out in the summer, early fall timeframe as well. So I think we'll be okay logistics-wise, and we should still be able to finish out the work ahead of us.
Mark. Thanks. Mark Carroll for Aviation Weakness, also for Kenny Todd. Can you elaborate a little bit more on the failure modes of the fan pump separators? Did they just not start so you can't do a spacewalk, or could they fail during a spacewalk, and what would be the consequence?
Sure. Relative to a condition for going out of the hatch is we have to have the fan pump seps running. It needs to be spinning in order for us to go outside. In this instance, for the two suits that we're talking about, we haven't had any issues at this point with the fan pump seps and them not spinning up. And so we feel very good about that at this point. One of the things that we are working on is to make sure that we're comfortable that once the crew is outside the hatch, that there won't be any degradation associated with this corrosion that could cause the pump to seize once you're outside. Now, if you encounter that scenario, again, our ops guys here will tell you that that's something they understand exactly what to do when they hit that scenario, and all the way up to getting the crew back in. There's a totally separate backup system in the suit that provides plenty of capability for the crew to return and ingress the airlock and get back on O2 back in the airlock. So from that standpoint, this is not a risk to crew, if you will, in terms of loss of life. This is, we want to go out of the hatch. We want to make sure that we've got suits that'll run for the entirety of the EVA. But if there's anything out there that surprises us once we get out there, we have a way to deal with it, and it's the same way that we would have dealt with any other failure in that particular area leading up to this one.
And just to follow up, I think that's the 30-minute emergency oxygen, but also wondered if you could talk about the heritage of the fan pump separators in the two suits that are assigned to Wilmore and Virts.
Sure. The suit that Terry will be in, we refer to as 05, that particular fan pump sep was installed in December. That was indeed the first suit that had the fan pump sep that didn't spin up. And so we flew another one up and installed it in the early December timeframe. And again, that one has been through several cycles since that point. We're continuing to keep our eye on it in terms, one of the signatures that you see with this corrosion is you see a higher current signature draw on the motor, and there's nothing there that at this point that's leading us to believe that it's going to seize up. We are seeing some peaks in the data that lead us to believe there is some corrosion in the bearings at this point, based on water getting introduced into the backside of the fan there. But again, a large part of what we're doing now is trying to assure ourselves that corrosion is limited to the point that it won't cause the fan to have a problem once it goes outside, and that we can get through the EVA without an issue. So a lot of work going on in that area. The other suit with 03, that's the newest suit on orbit right now, and to my knowledge, that is the fan pump sep that went up with that suit. So we haven't changed that one out at this point. I will tell you that once we suspected that we had a problem in this area with water getting behind this fan, these fans, based on the number of times that we're cycling the fan pumps and putting extra water into that area, we implemented a dry out procedure that allows us to get a little more airflow in that area. So at least these two suits, we've been able to, through the last series of flushes that we've done, implement a new strategy for getting a little more air into that area and drying them out, so that we can minimize any further degradation to the best that we can.
Robert?
Robert from Collect Space. Just to work off Mark's question and to verify, you said the timing would depend on your understanding of the fan pump. But as of right now, you're still working towards Friday being the first spacewalk, correct?
At this point, I think I'm gonna hedge a little bit on that. I've got an IMMT, a mission management team meeting tomorrow morning. I think there's enough data still left on the table that I'm not going to throw that out here and say we're absolutely going to go on Friday. I don't want to put that kind of pressure on the team from a schedule standpoint. I know there's enough work being done and analysis still to be completed. I'm not saying we can't do it, but at this point I don't think I want to necessarily stamp approval for Friday on it just yet. I want to wait and get through the mission management team in the morning and see where the team stands and see where the data leads us.
And if you did have to delay that first one, is it a day-for-day slip with the others as well?
Our thinking at this point, with this being a triple, and knowing that we've got, Butch coming back here in the middle of March, we're operating in a window here, trying to figure out the best way, if we don't start this triple set on Friday, how to do it in a way that it doesn't totally derail some of the other things we have going on between now and when Butch comes home. So our thinking right now is to try to stay on the dates that we have. So if we don't do the first EVA on Friday, chances are, based on whatever it is that drives us off of Friday, if it's additional data, if it's completion of testing or whatever, our best guess probably is to try to go to Tuesday, which is where our second EVA was at this point. And so that way we can kind of keep the spacing, and we'll just evaluate the third EVA, and if we have time on the back end, we'll drop it in before we bring Butch home, if everything's continuing to look good on all the different fronts.
Okay, we'll go ahead and go to the phone bridge at this point. Again, if you have a question and you're on the phone bridge, press *1 and you'll get added into the queue. So why don't we go ahead and start off with space.com.
Hi, Kenneth. Can you tell us if there's a deadline by which you have to make a decision if the spacewalk will go ahead on Friday?
Well, I think I've got all the way up till tomorrow. Probably about middle of the day, we need to get the word on board to the crew. Our ops team needs to start getting into the final preps, which means the team that's going to execute the EVA needs to know that so that they can get the proper personnel rested and ready to go. So I think we've got a little bit of runway, but again, we can't run it too late into the day tomorrow, just because of the crew day and making sure that they're fully aware of what we're thinking.
Okay, that's all we have on the phone bridge for right now. Let's take a couple of social media questions. We've been soliciting some from our followers. I think we have time for one or two.
Yeah, I think we're getting a lot of questions on social media, but we only have time for a couple. So this one comes from Margaret on Twitter. She wants to know, what will be the most challenging aspect of Friday's EVA for Butch and for Terry?
Friday's EVA?
Or the first one.
The first one. Most challenging. Probably just the overall length of the number of cables that they need to route and keeping that straight. There's nothing that's very especially difficult about this EVA, but it is a lot of cables and wire ties to manipulate and things, so some hand fatigue.
And I think that's a good segue into the next one. Understand the astronauts will be routing cable outside the station. What activities did they do on ISS to prepare for that before these spacewalks?
I know Butch told me that he was doing the hand exercises that they do, so they're making sure their hands are in good shape for that, as well as, of course, all of our normal EVA preparations that they do, studying the timelines and getting their suits ready. So.
Okay, let's take a couple of quick follow-ups here in the room. Mark.
Mark Carreau for Aviation Week for Arthur Thomason. I'm sorry, I think I made some notes on the kinds of communications that will be covered with these two different antennas, but could you go over the range again? Is there some navigation and guidance in there? Is it voice, that kind of thing?
It's rendezvous and docking for visiting vehicles, yeah.
And so it's just telemetry, I guess, exchange.
That's right, and there's also reflectors that are installed, and so lasers are shined on those reflectors for range finding with docking.
Okay, Eric?
Yeah, just a quick follow-up. How many runs in the NBL did these guys do in preparation for each of these spacewalks? Would they do like, EVA 29 6 times in the pool and then do EVA 30, or did they kind of combine the tasks to prepare?
Yeah, we Butch and Terry saw the first EVA. They each saw it once with a different crew member, and they saw it once together. In the post-shuttle era, we don't get to practice every EVA multiple times like we used to, and so we have changed our training so that it's a skills-based kind of a thing. So they get, I think it's 10 NBL runs through their entire training that covers all of the contingency things they could need to repair on the space station, as well as skills they might need to do on planned EVAs.
As far as EVA 30 goes, the crew did run some runs the first half of the EVA with removing the PMA2 cover and then finishing the cable routing. As far as the lead lubrication, we had some work just in a 1G environment because the hardware at the NBL wasn't mocked up to the highest fidelity that we need to do to actually get the lubrication in all the spots. So Terry did do a run in the NBL with a lead that was basically an empty cavity of the latches. So they have some great training videos on board, and they're practicing using the BLT to get to the lubrication spots. And then the rest of the EVA with Butch on Node 3, it's rather that standard ops of removing hardware and bolts and things. So
no pressure that this is dress rehearsal and opening night, like all in one for the spacewalks.
They're great crew members of EVA crew members. I mean, they're fully qualified to do it, but we don't anticipate anything surprising during these EVAs, since even though they didn't do a full end run-to-run of these spacewalks.
Okay, one more real quick, Robert.
Rob Perlman with Collect Space. Just stepping back for a moment, if these do get off this week or next, they're coming about a month before the 50th anniversary of EVA. Can anyone who wants to take it talk about what the complexity of this EVA sort of says about how far we've come in the past 50 years?
Yeah, so I mean, from EVA 30 standpoint, lubricating the LEE, was never intended to be lubricated that way. It's been on orbit for a while, and they think it needs some of this wet lubrication just for the fact that you develop a tool that's on board, you develop a tool out of items that are on board to lubricate what you actually need to fix it, because we can't bring it home to fix it. I think that does say a lot of how far we've come of adapting to hardware being up in space for a long time and fixing things with what you have on orbit to get the job done.
I think kind of to build on what Karina says, we've changed things since the shuttle era too, where we would do maybe 10 runs in the water. They would get this EVA choreographed. The crew knew every single detail. Where now we plan it on the ground, get it ironed out on the ground, and we send them up briefing packages, videos, the graphic like you saw that we showed here. All that stuff helps the crew study on board and minimizes the training they have on the ground.
Okay, well, that's going to go ahead and wrap it up for us today. Thanks again for joining us for this EVA preview briefing. And as always, you can go onto our website, get all of the latest times, coverage times, and the latest information on these EVAs as they get ready to unfold at www.nasa.gov/station. Thanks, and enjoy the rest of your day.